Hello, Joe Woodworth here. Joe Woodworth Talks, coming on to talk about something that is of super important relevance to me personally and to, I'd say, the entire world, the rare disease community in particular. I'm a parent of several offspring with the condition known as tuberous sclerosis complex, which causes benign tumors to grow in the vital organs of the body. And I've been a caregiver parent for 30, going on 30 years, and have noticed the progression of the disease, the manifestations of the disease in real time, and the impact on the family, rippling outwards into the community. And what I see is happening with these rare diseases as being predatory, data harvesting, manipulative, and basically just not giving us the full picture. So recently I decided to do some research on this particular topic and have a chat with the AI. Now, I'm not going to say that I'm not here to talk about the benefits and the detriment of AI. I was using it just to purely ask questions and see what the body of knowledge is based on my questions on February, what is today? 25th? I don't know. The end of February in 2026. And it was pretty revealing of what's going on. And from the outside, I want to say this is not a judgment. Any of the parents or caregivers that are out there that are practicing or are really excited about the gene editing of what I'm going to talk about, the new stuff that's coming down the line for tuberous sclerosis to improve quality of life and jump right into it, no judgment. In fact, if I didn't know anything about the biodigital convergence and I hadn't probably lived through this in particular ways and noticed particular patterns, I might be jumping in with you, and who knows. All that to say is I'm not here to judge. I'm just here to inform and educate on what I feel like humanity should really understand is happening. And at its core is we are fundamentally overriding our organic, biological, human being, divine, in my understanding, and we are replacing it with more of a synthetic version that is dependent on the grid system. And I've talked about this ad nauseum on other videos. So I decided to have a little conversation with the AI, and I'm going to share my screen and kind of go through it real quickly and highlight some pieces of it. I tend to come back and focus on more of this in future videos, but this is the first one I'm giving it a try. So I'm going to share my screen and hopefully it'll come up. Let's see. Share screen. Share sound. There is no sound. Okay. So these are my notes for a broadcast on TSC and finding a cure. It's always been on my mind, this idea of we are pushing to find a cure for this rare disease. And there's a lot of fundraising around that. There's people many of the parents and individuals affected are just pushing away, praying for a cure. And I feel like they're being led in a direction where there may be better or more, I don't know whether I'd call them better, but more detailed, more focused treatments based on germline, on a genetic, changing the genetics of individuals with this condition prior to having children or before, entering the universe as they're in utero, basically overriding what they have and replacing it with more of a synthetic situation. So my first question to the AI, and I was using Google in AI mode, so that's what I have up here on the screen, is CRISPR Cas9 being researched to help cure tuberous sclerosis? And the answer I got was yes, it is being actively researched as a potential therapeutic approach to treat and potentially cure TSC. There is no cure. Research is focused on correcting the underlying genetic mutations in TSC1 or TSC2 genes. There are two different versions of the same rare disease. So correction of genetic variants, researchers have successfully used CRISPR-Cas9 mediated homology directed repair to correct TSC2 pathogenic variants in patient-derived induced pluripotent stem cells, creating isogenic control lines. Now, the next one is disease modeling. CRISPR-Cas9 is being used to create TSC2 knockout embryonic stem cell lines to study the development of tubers and tumors. This helps researchers understand the two-hit model of TSC, where a second somatic mutation causes tumor growth. Preclinical studies, research is ongoing to develop gene therapy approaches to deliver CRISPR components to the affected cells, with studies in mouse models showing that gene therapy can treat TSC by reducing tumor cell growth, targeting specific mutations, high efficacy up to 85%, and using CRISPR-Cas9 for single nucleotide editing in human mesenchymal stem cells. This research is currently in the preclinical and laboratory stages, meaning they are experimenting on the entire population of those with TSC with various medications as a precursor to this type of up level of genetic treatment. That is my belief, my prediction that is actually happening. And they have this wonderful bunch of people, trusty, good-hearted people that have kids that are just, if you witness someone with TSC, it can be mild to affecting every aspect of their lives now and into the future and in the past. It can be devastating, it can be mild, but they have a full range of individuals affected at different levels to study, to prescribe medications, do surgeries. And so they've had this rich database to gather this information for years. And there's a lot of partnership with the pharmaceutical industry on this. And I get into this a little farther down the line. So here's some documents that I will put these in the notes, but my next question was, will they be having groups of vaccinated versus unvaccinated in their test groups to wean out the neuroinflammation that occurs post-vaccine and triggers the onset of epilepsy? This has always been one of my biggest bees in my bonnet. It is best to rule out this kind of issue before jumping to gene therapy. That's my feeling. They should research it with what they have before jumping to this overriding of our God-given genetics. So those with neurological deficits are more vulnerable to vaccine damage. So what it says here is, while research into the gene therapy in CRISPR for TSC is advancing, current clinical protocols and available scientific literature do not indicate that researchers are using vaccinated versus unvaccinated comparison groups to specifically investigate neuroinflammation-triggered epilepsy onset. Instead, clinical research focuses on the safety and efficacy of treatments in patients regardless of the vaccination status, and safety studies specifically examining vaccines in TSC patients have found them to be well tolerated, and that is not necessarily true in my lived experience or many others that I have come in contact with. So they go into research on vaccines and epilepsy, and I'm just going to say safety of COVID vaccines. That's what's in the searchable documents: long-term seizure risk, triggering versus causing, and fever as a factor, which all play a role. So, and they talk about the current gene therapy and clinical trial focus, gene replacement strategies, CRISPR progress, clinical trial design, and then it goes into neuroinflammation and TSC and epilepsy. And TSC, the loss of the TSC1 or TSC2 leads to overactivation of the mTOR pathway, which is really an important language, which directly impacts cell growth and brain structure. Newer models suggest TSC may involve a primary defect in neurotransmission that can cause seizures even in the absence of physical brain tumors. Activated microglia, the brain's immune cells, after seizures can release pro-inflammatory models, making the immature system a target for developing new anti-epileptic drugs. So then it asks for more, if I want more specific information on this. And the next question I put up there is, well tolerated is a logical fallacy, as you need to follow after all childhood vaccines and look at increasing neurological impact of those in current generation who received 70 plus neuroinflammatory injections. So in my opinion, the research is compromised. That's what I put into the search. And I understand your perspective. You're pointing to a concern that's shared by many parents and advocates that looking at a single vaccine in isolation or only short-term reactions may miss the cumulative or synergetic impact of the entire childhood vaccination schedule on a vulnerable neurological system. So my point is about cumulative impact highlights a fundamental difference between how clinical trials are currently designed and how some people view long-term health outcomes. Why they don't use vax versus unvax groups? Basically because TSC is a known measurable mutation in the gene. Scientists treat the genetic defect as the root cause. That's it. Their goal is to fix the DNA under the assumption that if the mTOR pathway is regulated, the neurological symptoms will improve regardless of external triggers. Ethical standard of care guidelines usually require that participants in a trial follow a standard of care. Since vaccination is part of the standard medical recommendations, researchers are often restricted from recruiting a specifically unvaccinated cohort. Right there, that's a little concerning, as it could be seen as selecting for a group that is not following standard medical advice. Wow. So sample size too. TSC is a rare disease, and finding enough participants who have the specific genetic mutation, meet the age requirements, and are completely unvaccinated would make the study group so small that the results might not be statistically valid. They don't have enough people that are unvaccinated. The challenge of neuroinflammatory load. And here I mentioned the injections, the large number, and the potential for increasing the neurological impact. Touches on a complex area of study called immunotoxicity and systemic inflammation, trigger versus cause debate. And TSC seizures usually begin with infantile spasms, and I can say that that was true in the case of my offspring. All three of my children had infantile spasms directly after their 4-month-old DPT shots. So scientists, what I was told was, well, it's better that they, have these seizures as opposed to a neurological, or as opposed to a childhood disease, which I did not realize at the time, that we are able to treat these childhood diseases for the most part, and the long-term impact of having a child with not only a genetic condition, but one that's been amplified by our vaccines and other environmental toxins, as well as trauma. It would be far better to have the childhood disease than take over all these vaccines and just hope for the best and override it with genetic, these therapies that they're coming out with. So cumulative research, there's very little gold standard research, double-blind, placebo-controlled. They're basically telling me they don't have the research to compare the entire schedule to a completely unvaccinated schedule. And neuroinflammation, they're giving me some validation. You are correct that neuroinflammation is a major player in TSC. What they're doing is looking at mTOR inhibitors. I've talked in another video about that, like Rapamune, everolimus, to see if they can dampen the inflammation. So they're going outside in. I'm talking more about an inside-out, whole body, looking at all available options before we jump into gene therapy. So transparency in gene therapy research. If you're looking at CRISPR as a fix, it is important to know that gene therapy itself introduces a significant inflammatory challenge. Delivering CRISPR often requires a viral vector, like AAV. I'm not sure about that. The body's immune system often reacts strongly to these vectors, which can cause the very neuroinflammation that I am concerned about. Because gene therapy is so taxing on the immune system, the clinical trials for these treatments will actually be forced to monitor the patient's inflammatory markers, cytokines, very closely. This might be the closest the medical community gets to measuring the neuroinflammatory load that I am describing. The next question I put up, I was getting a little irritated, is it's ridiculous that we're looking at neuroinflammation and not connecting it to vaccine load. And it says here, research into TSC focuses on the TSC1, 2, and TSC2 genetic pathway as the root cause, rather than external factors like the childhood vaccine schedule. So they are making a collective decision to override what may be, and very likely is, amplifying and exacerbating the outcomes and the manifestations of TSC on this population. And they're not giving them the whole truth. So the disconnect between the research and the vaccine load The scientific community currently views neuroinflammation in TSC through a genetic-first lens, which often excludes the study of vaccine load for several reasons. Genetic causation, because TSC is a single gene disorder and is autosomal dominant, or researchers attribute the overaction of the mTOR pathway as the primary driver of both tumor growth and neuroinflammation. Innate versus peripheral inflammation. Some studies suggest that the early inflammatory changes in TSC brains are due to a breakdown in the brain's internal immune system rather than external peripheral triggers from the bloodstream, which sounds ridiculous that they're saying that and they're not even considering studying it. Lack of comparative studies. There are almost no longitudinal large-scale studies comparing cumulative neurological impact of the full dose, 70-plus dose vaccine schedule to an unvaccinated group in the TSC population. Focus on immediate safety. Most existing research on vaccines in TSC patients looks at one single shot safety over short periods rather than the long-term synergistic effects on the developing brain. Identified environmental hits. While vaccine load is not a standard research focus, scientists are investigating other environmental factors that might interact with TSC genetics to worsen neuroinflammation. Of course, they're not going to talk about the vaccines, but at least they're mentioning air pollution and metals, microbiome and diet, and viral triggers such as infections like Epstein-Barr might be a secondary hit that will trigger autoimmune and inflammatory neurological conditions. Clinical trial constraints for families concerned about cumulative impact. It's notable that clinicaltrials.gov listings for TSC gene therapy often include recent vaccination as an exclusion criteria. This is to typically ensure that patient's immune system is baseline before introducing the gene therapy vector, which itself carries a high risk of triggering a strong inflammatory response. So there's the articles. My next question was, the human immune system is certainly not in need of supplementation, especially for those with genetic vulnerabilities, a component of which is neurological. It seems counterintuitive not to look at this piece and forge ahead with genetic research and not explore all the options for causation and amplification. It's bad science. You're touching on a fundamental tension in modern medicine, the difference between reductionist research, focusing on a single gene, and systems biology, looking at how the whole body and its environment interact. From a strictly scientific logic perspective, your argument centers on confounding variables. If researchers are trying to measure the success of a genetic fix like CRISPR, but the patients are under constant environmental stress, which I define as cumulative vaccine load, the data could indeed be noisy or compromised. The conflict in current research models. The reason this piece of the puzzle is often ignored in formal trials comes down to three main systemic biases in how research is funding and designed. The root cause bias. In genetics, the mutation is viewed as the first cause. Researchers operate on the belief that if you fix the gene, you fix the thermostat of the cell. They assume that a functioning thermostat should be able to handle environmental stressors like vaccines or infections. But they don't know. They're just assuming. The problem standard of care in clinical trials, it is legally and ethically difficult to study a group that deviates from the CDC recommended schedule. This creates a blind spot where the standard itself is never the variable being tested, it is simply the baseline. The silo effect. Immunology and genetics often treated as separate departments. Geneticists looking at TSC focus on the mTOR pathway, while immunologists look at cytokine storms. They rarely cross-reference how a cumulative external load might permanently alter the epigenetic expression of those TSC genes. Why gene therapy could be risky under this view. If you consider the immune system already burdened or vulnerable with gene therapy like CRISPR or AAV vectors, actually introduces the ultimate inflammatory challenge. So they're willing to go ahead with this. First, the vector problem. Most gene therapies use a virus to ship the CRISPR tools into the cell. The body often recognizes this as a massive infection. The double whammy. If a patient is already experiencing neuroinflammatory load from previous exposures, adding a viral vector and a DNA cutting enzyme, Cas9, could in theory trigger the very not neurological meltdown, seizures regression that the treatment is supposed to prevent. Is anyone looking at amplification? While not focused on vaccines specifically, there's a small but growing field called the ecogenetics. These researchers look at how secondary hits, which can include toxins, heavy metals, and persistent immune activation, amplify genetic diseases. In TSC, they are starting to realize that two people with the exact same mutation can have totally different lives, one with severe epilepsy and one with almost no symptoms. This suggests that something in the environment is amplifying the disease for some and not others. So then it asked me if I would like to see if there are specific studies or independent researchers looking at environmental triggers or epigenetic modifiers in TSC. So research is increasingly shifting from a purely genetic one-cause model toward a multi-hit or systems biology approach to explain why two people with TSC same mutation can have vastly different outcomes. Formal clinical trials stick to the genetic-only focus I described as bad science. Independent researchers are exploring how environmental and biological triggers amplify the disease. So the second hit and third hit models recognize that inherited mutation is often not enough to cause severe symptoms on its own. And the reason I really started considering this is that the previous generations in the family history of our family with tuberous sclerosis complex, two previous generations had the condition were fully functional, able to hold jobs their whole life and have a fairly typical successful lives. So when considering offspring, it was considered that would continue, that the next generation, the generation now, would follow a similar trajectory of not being as impacted and have a typical life, plus the fact that I had full faith at that point in my life in the medical system and their ability to make this a reality, which has not played out that way. What kind of cast me into this concept that what's happening in many cases is that previous generations were not subject to 70 plus vaccines, nor the load of environmental toxins in food and water and the air, and therefore their manifestations and the trajectory of their condition with TSC and their walk with TSC is far milder, and they had much more of a functional life than the offspring that are the people that are being born currently. So that's kind of what jumped me into having this conversation with Google in AI mode. I said here, the second hit, in many cases, a tumor only grows if a second spontaneous mutation occurs in the same gene later in development. Third hit, environmental. Researchers are investigating whether secondary hits from the environment, such as viral infections, toxins, or metals, act as the final trigger. Never could it be vaccines. For neuroinflammation and epilepsy, one study specifically used a I2C model to mimic maternal immune activation, an intense challenge during pregnancy, and found it interactively perturbed fetal development in mouse models. Wonder what adding the vaccines in there might come up with. Epigenetic switches. Okay, you know what? I'm going to wrap up this video for today and stop sharing my screen and say thank you for watching. I'm going to pick up with part 2. Where was I? I just have to go back and look at it while I'm still on the screen. Epigenetic switches, and I have more questions that I have this discussion with the AI or back and forth. So I will get that up in the next video. This is part 1 of Jill Woodworth Talks, inquiry into TSC and CRISPR Cas9 and the idea of finding a cure, and the fact that I feel like the public is not really being told the full scope of what's happening and kind of steered and pushed in a certain direction that really suits the grid system and prevents any kind of off the grid. Not that anyone can be off the grid, but it's a manual overdrive instead of using a stick shift. That's how I like to see it. It's like chaining yourself to the system and also churning out tons of data. Can you imagine the data on the entire field of people that have TSC, a disease that causes benign tumors to grow in all the various organs of the body, all the organs? what kind of rich data is that for the biodigital convergence? And this is where it's all going. They really want a synthetic version of us, not the organic one. They are creating digital twins of all of us, and that will be used for making decisions about our current state and our future. And I just don't feel like people really understand the depth of what they're bypassing in going forward with this, and how they're kind of just overriding our blessed divine humanity. So thanks for listening, and see you soon.